So let's say you know how to use a computer and you can program in Python, but you're new to C. And there's a few things to be a little bit mindful of. And first one is that C is a compiled program. So you must compile the code, whereas Python can be interpreted. So if I want to do some Python, I can run it at the command line. Very simply, there's no compilation step. Okay, so this is the first thing. C programs, you can't run at the command line. You must type the code, then you must compile them, then link them, and then you execute them. Python, you can write it at the command line like that in the Python interpreter, or you can save it as a .py file, and then that can be run inside the interpreter. So that's the first thing. Second thing is the efficiency of C. Although it's a much older language, it's lower level, it's closer to the hardware. So it's significantly more efficient than doing something in Python. Now, the exception is if you're using a Python library which is optimized. So a very good, efficient Python library, things happening inside there may well be more efficient than if you code that yourself in C. I've got an example C program on here. Let's just look at the actual code itself. C programs almost always start with some hash includes that takes the content of something, in this case header files, and copies it into the code here. And there's hash defines, and there'll be functions just like Python has functions. C also defines their functions. In C, the first function that gets run when your code executes is not the thing at the beginning of the file, it's main. So somewhere in your file there's a main function. That's the thing that gets run first. Okay. In C, the curly brackets denote the code blocks. So in Python, indentation matters. So if this binomial parity was written in Python, you wouldn't need the curly brackets, but the indentation of the if and the return, they would tell you something about which code is inside the binomial parity function. In C, it doesn't matter if it looks like this, or like that, or like that, it will still run perfectly fine. Okay, the curly brackets tell you about which part of the code associates with which other part. Give you another example. Down here we've got an if. So the person that wrote this code, which was not me, they like to put the starting curly bracket just there. I like to put it just here because I think it makes it easier to read. In Python, you wouldn't need the curly brackets at all, and it would be clear that the fprintf and the return are associated with the if function. It would be clear because of the indentation. But in C, the indentation doesn't make any difference. Other things, every valid statement of C, not the hash defines, because those are the preprocessor statements, but every C statement must end with a semicolon. Right? Yeah, and in fact, I can stack up statements if I really want to, like this. Yeah. Comments, they start with this slash star. Variables are all typed, so int u, int 8, and so on. Let's see if there's any more variables down here. None. And usually variables are defined at the top. So at the top of main, the variables are normally defined, which are used in main. You generally in C, you can't define variables lower down in your functions. They should be defined at the top of the functions. C code can be very simple, but it can also be quite complicated. So it makes sense for you to know how the curly brackets work and how to decompose complicated lines into the functions, into their functionality. We also note that C has got you use pointers, and this is really important because a lot of things in C you can only do if you use pointers. So this star indicates it's a pointer. So A is a variable which is a pointer to an unsigned 8-bit integer. That's what this is saying. So if you program in Python and you're converting now to be programming in C, one of the things you need to learn is pointers, okay, because you don't get that in Python. The other thing that you need to do in C is memory management. So we will generally not do this, but typically a C program, you need to allocate space in memory before you can fill it. So the calloc, or alloc, malloc, calloc, and realloc, these functions, if you see them, they mean allocate a space in memory. Okay. They're actually similar to defining an array in some ways, except that you're not filling the array at this point. Yeah. After you've used the memory, you're required to free it.